3-2 triangle theorem. So what we're going to look at today is, first off, what happens to the angles inside the triangle, and then we're going to look at what happens when we talk about an exterior angle today. So let's talk about the angle sum theorem in a triangle. So if we take all three measures of the angles in a triangle, it's always going to add up to 180 degrees, no matter what. Those will always add up to 180 degrees. So in this case, we could say angle A plus angle B plus angle C is going to equal 180 degrees. That's the theorem you need to know about triangles. So anytime they give you anything about the angles, it's always going to add up to 180. So let's practice that here. So if we just kind of concentrate on this example first, we're going to use some of our vocabulary from previous units, and we're also going to use our triangle sum theorem. So if I look here, I see a triangle. I see that I have two of the three angles, so what I could do is add those two up and say 56 plus the 78 equals 134 degrees, but then I would take that away from 180, and that would leave me with 46 degrees, and that would give me the measure of angle W. Well, if I look here at W and X, I see that W and X form a linear pair, and we know that if it's a linear pair, then it adds up to 180 degrees. So I could say 180 minus what I know W to be, which is 46, and it leaves me with 134 degrees. So that gives me X. Now, another thing I know, and I'm going to highlight this in blue, is this angle here at W and the one across from it are vertical angles. And remember, vertical angles are congruent. So if we know W is 46, then we know the one across from it is also 46. So now I have another triangle here in blue, and I can use the triangle sum theorem there too and say, okay, well, 46 plus 81 gives me 127. Subtract that from 180. And that leaves me with 53 degrees. And so that's what Y would equal. The next example here is saying, okay, well, let me give you something for all three angles. We know to add them up and set them equal to 180. So we would take all three angles, add them together, so there's one angle, there's the second angle, and there's the third angle, and that's all going to add up to 180 degrees. So if we were to combine our like terms, 4x plus 3x plus 6x, that would give us 13x. Negative 12 and negative 16 gives us negative 28. So there's our like terms combined. Add your 28 to both sides. 13x equals 208. And if we divide by 13, x equals 16. Okay, so they want us to find the missing angle measures. X does not show you what the missing angle measures are. We have to plug them in for every single angle. So if we go up here and say 4 times our x, which is 16, that's going to equal 64 degrees. If we plug this one in and say 3 times x, which is 16, minus 12, gives us 36 degrees. And our last one here, saying 6 times 16 minus 16 equals 80 degrees. And if we wanted to check, we could take all three of these angles and add them together, and it will add up to 180 degrees. So that's your interior angles. They'll always add up to 180. Now let's talk about our exterior angles. So right down here it says the interior angles of a triangle not adjacent. And remember, adjacent means next to, so not next to, a given exterior angle are called your remote interior angles. So if we look at this picture, we can see the arrows pointing to A and B, points A and B. Those are your two remote interior angles. So we can go ahead and fill that in as angle A and angle B. Our exterior angle is down there at C. Well, we can't just say just angle C because C is talking about actually two different angles, one on the inside of the triangle and one on the outside. So if we want to specifically talk about the outside one, we would follow this path, okay? And that path goes from angle points A to C to D. Okay, so here's your exterior angle theorem that you need to know for today. The measure of the two exterior angles of a triangle is equal to the sum, so we add them together, of the measures of the two remote interior angles. So if we add the two remote interior angles, if we were to add angles A and angles B, we would get the measure of our exterior angle ACD. So let's practice that on some of these equations here. So let's start with this one. Our two remotes here are in blue, okay? If we add those together, it's going to equal our exterior angle. So let's set that up in equation. Our two remote interior angles, if we add them together, it's going to equal our remote or our exterior angle. So combine your like terms. 7x plus 33 equals 14x minus 16. Combine like terms, subtract 7x over, that gives me 7x. Add 16, that gives me 49. Divide by 7, and x equals 7. Okay, we need to plug that in and find our angle measures. Or no, it's just asking for x and y. That makes it even easier. So we know x is 7. Now, the only way to find y, you could do it a couple of ways. You could plug x in and figure out y from your interior angle sum, or we could plug it into the exterior and subtract from 180 because these two in pink create a linear pair. So let's go ahead and do that. So if we say 14 times 7, because that's our x, minus 16, that gives me 82 degrees. But that one is our exterior angle. To get y, we would subtract from 180, and that gives us 98 degrees. Okay. The second example that we're going to look at here, and we need to scoot that angle over. It got shifted over. So we would say our two remote interiors, so here's our two remote interiors, and they would add up to our exterior. So we would say x squared plus 5, there's one remote interior, plus our second remote interior equals our exterior angle. So combine our like terms, x squared plus our 8x plus 15 equals 16x. We have that x squared, so that tells me I'm going to have to factor, so let's move our 16 over. So we're at x squared minus 8x plus 15 equals 0. So if we're going to factor, remember we do our x trick, a times c and our b. Our a is 1, our c is 15, so that would be 15. Our b is negative 8. So two numbers that multiply together to get 15 and add up to a negative 8. We know our product number has to be is positive and our sum number is negative, so that tells me that both of these are going to be negative numbers. So negative 5 times negative 3. So I can just put x minus 5, x minus 3, because there's not a coefficient. It works out that way. And so if they're wanting us to find the measure of the exterior angle, we have to know what x is. So if we set these equal to 0, I can solve and x would equal 5. I can set the other one up equal to 0 and x would equal positive 3. So what happens here is, because both of these are positive, I could actually have two different solutions here. So I could say 16 times 5, which is 80, or 16 times 3, which is 48. Okay, those are your two possible solutions here. Okay, we're going to shift gears for a little bit and talk about specific kinds of triangles. So if we look here at the picture, it wants us to classify by the sides. Well, I see here that two sides are congruent, and if two sides are congruent, that means this is an isosceles triangle. Legs are your two congruent sides, so our two legs are AB and AC. The base is the non-congruent side, so that is BC. Base angles are on either side of the base, so we would say angle B and angle C. And our vertex angle is the one that connects the two congruent sides, so that would be angle A. So with an isosceles triangle, basically what these theorems are saying is if you know the two sides of the triangle are congruent, then the angles opposite them would be congruent, which would be your base angles. So if I know my two sides are congruent, I can go ahead and mark my base angles congruent. Kind of the converse, remember converse means switch. If I know my base angles are congruent, then I know my legs are congruent. So let's practice that on a couple of questions. So do you see here in this first example how A and B are congruent? Those are your base angles, which means your legs are congruent. So we could go ahead and mark those two being congruent. Then we would set them equal to each other because they're congruent. Combine like terms, move your x over, that leaves us with x. Add the 4 over, that leaves us with 9. And so since they're asking for the length of AC, we would take our x and plug it in. 2 times 9 is 18, minus 4 gives us 14. Looking at the next example, I don't have anything congruent at the moment, so we would use our triangle angle theorem. So let's add our 56 and 62, and that gives us 118. Subtract from 180, and that leaves us with 62. And so now that I know angle F is 62 degrees, I can see that my base angles here would be angle F and angle H. Now I know who my legs are. We can mark those as being congruent. So if FG is 42, so will GH, and that would be our answer. Last bit here with equilateral triangles. If your triangle has all sides congruent, that means all your angles will be congruent, and vice versa. If all your angles are congruent, that means all your sides are congruent. So let's break these problems apart here. I see two sides being congruent, which means our base angles are going to be congruent. I also see that I can use linear pair here to find that missing angle. So 180 minus the 122, which gives us 58 degrees. So that would be this angle. But because you have an isosceles triangle, both of those angles would be 58 degrees. Then, because I know all angles in a triangle add up to 180, we could add up 58 and 58, which gives us 116. Subtract that from 180, and that gives us 64. And so that would be your vertex angle at the top. Then I could use vertical angles here. Both of those would be 64. I have another isosceles triangle, so if I know my legs are congruent, so are my base angles. I'll mark those in pink. So both of those would be 64. I could use my triangle sum theorem, add up my 64. Which gives me 128. Now, I could use my exterior angle theorem and save myself some time of adding and subtracting from 180 twice, because these two are in pink, my remote interior angles, they add up to my exterior angle, so I am actually done with X. Last example. I see that in this triangle here that I'm highlighting, it's equilateral, and if it's equilateral, all sides are the same and all angles are the same. And if we take that 180 and split it equally 3 ways, we know that all angles are 60 degrees. I see a right angle symbol here, so 60 plus what gives me 90 would be 30 degrees. Now, when I look at this other triangle here in green, we notice that we have an isosceles triangle. Two sides are the same. So if two sides are the same, the base angles are the same, which means X would equal 30 degrees also. And then if I use my triangle sum theorem, I could add my two base angles, subtract from 180, and that gives me 120 for my value of Y. So break that triangle into two pieces. Don't look at it as one big picture. Look at it as two separate pictures. One, we have an equilateral triangle. Use that information. And then look at your other triangle and transfer your information over